Hi, my name is Brett Glazer. I'm the MEA Laboratory Manager here for Vitrolife. I've been working in the MEA lab since 2008, and our mission has been to create the most sensitive MEA assay possible to ensure the quality of the products that Vitrolife is producing. MEA is a mouse embryo assay, and it's utilized to detect toxicity in compounds and to assist us in evaluating the quality of the media that's manufactured. For MEA, we use the one-cell mouse embryo, and we expose media or the mouse embryos themselves to the materials or the products that we're producing. The assay is a 5-day assay that allows embryos to develop to the blastocyst stage, and then we can make qualitative and quantitative assessments on the quality and the toxicity present for the materials that are used. The way we do MEA is to take a raw material and expose it to our simplified media and utilize that media in the culture of one-cell mouse embryos. The mouse embryos are placed into a culture environment for 5 days, and at that point we determine the number of blastocysts that have developed on day 5. The development of blastocysts to day 5 is used as the criteria for release of finished products. And what we see in our laboratory is that morphologically we may have embryos that look very similar, but using a technique of cell staining, we can go inside the embryo and actually determine the viability by counting the number of cells that are present. We can do this by doing a total cell count, or how many cells make up the inner cell mass and the trifectoderm. And for specific raw materials that may be more sensitive or more variable, we can use a dual stain or differentially stain the embryos, looking at specifically the trifectoderm cells and the intercellular mast cells. An assessment is then made between the test and the control to determine whether or not a material will be passed and utilized in the manufacturing process. This is also performed for the finished product, and this allows us to determine whether or not a finished product meets our quality standards. Over the years, there's been a transition from the 2-cell mouse embryo to the 1-cell. The 1-cell mouse embryo is the most sensitive stage of embryo, so it makes sense to begin at this process. And we see this with most manufacturers using the 1-cell mouse embryo. Another way to increase the sensitivity of the assay is by creating specific medias designed to remove the compounds that help support embryo development. Another aspect is to remove compounds such as albumin, as albumin can often mask the effect of these toxic compounds. In our industry, one of the criticisms about the mouse embryo assay is that it hasn't been standardized, and there's the possibility for variation in the results, potentially between laboratories or between investigators, because of the setup or the design of the assay. As far as the release of products, a MEA assay is required for the release of finished products, and that lends itself to some question about quality, as quality can vary, and depending on the sensitivity of the assay, that toxicity or lack of quality or inconsistency in quality might not be picked up. The release criteria for the MEA is a series of quality control tests, one of those, of course, being the mouse embryo assay. For the mouse embryo assay, we're required to indicate the blastocyst development on day 5. Vitrolife uses a series of additional endpoints to determine the quality and the viability of embryos that have developed when exposed to raw materials and the finished product. While this information often is not on the certificate of analysis, it's utilized in the determination of whether or not a product is released or if a raw material will be used in the manufacturing process. One of the aspects of the MEA test that we've designed is to optimize the test. Now, by optimizing it, what we're really talking about is creating an extremely stressful environment for these mouse embryos to grow. By removing the compounds that are typically in the media that help support embryo development, we can start to see the effect of the toxic compounds, specifically in the raw materials, and that allows us to eliminate them and deselect them so they're not part of the manufacturing process. The MEA has been designed to identify toxic or suboptimal compounds that are often enter the system. By identifying these suboptimal compounds, we can minimize the stress in the culture environment, which leads to the development of more viable embryos. More viable embryos ultimately leads to the increase in the clinical outcome. The MEA is the most valuable tool Vitrolife has to ensure safe and consistent products. This makes it possible for our customers to create an optimal environment for embryo development and ultimately helping patients become parents.